Hi, hello everyone, and welcome back. And just to recap last time, what we did is we created our texture, we loaded our texture, we could see it in a debugger, we were sure that it's created, and now we just have to use that texture. So let's get immediately started and waste no time. And in order to use the texture, we kinda need to actually start with the shader, right? So basically, we had it somewhere over here created. Now, in our shader, we have to make use of it. And for that, we're going to need texture coordinates. And texture coordinates, let's just quickly explain them. It's kind of visible from here. We have texture coordinates that usually go from 0 to 0 to 1 to 1. Although by default, these are actually OpenGL texture coordinates. The difference with WebGPU is OpenGL texture coordinates have origin here, but with WebGPU, they actually have origin here. So we're probably going to have to flip this texture around, I guess. But that's not an issue. We can deal with it later. Usually you just kind of flip this around. But what does this mean, this? Well, it's just when we create, when we need to sample the texture, and, we just use some texture coordinates so that we know which pixel do we need to sample, right? With the texture coordinates, and usually we just paste these corners, right? But of course we can also paste here 2, 2. In that case, we can imagine this part is repeating, right? It will go from here to here, and then you can imagine going from here to here again. But you can also specify direction here, but more on that later, because that's something that we're going to discuss when we have a sample and detection. Then it's going to be easier to discuss. So we're going to need the texture coordinate, right? Which is passed alongside our other vertex data, right? It's passed alongside position, color, and now we're just going to have texture codes. And it's of type vector f, right? And then we can output it because we're going to use it in fragment shader actually, so we just need to paste it along. I'm going to use actually text chord. It's a bit shorter, so we can say out. And in. And we don't have to use it yet. We're going to use it a bit later, but for now we can just actually pass that in, and we're going to do that here, right, where we had our vertex buffer. So we can just pass in here 0, 0. If we need to fix it, we can fix it later. So I'm just going to go with this -0, -0.5. So I should quick pass 0, 0. Here it's 0.5, so I'm going to say 1, 0. Then 0, 1. And here, let's be mindful of commas. If something doesn't work for you at the end, it might be because of that. Here it's bottom left, and there is bottom left is optional. So I guess we're going to have to flip this, right? As you remember, as I mentioned, the WebGPU has actually flipped origin for texture chords, so this should be good. All right, let's go a bit further. So where do we need to pass that in? And obviously we're going to need to, actually it's already passed, right, in our vertex buffer. So I'm a bit ahead of myself. We just need to fix it where I was assigning this pipeline. So it's, I guess, in device create pipeline we handled it. Ah, come on, don't be so slow. No utils, render pipeline util, and then here we were describing vertex attributes. So we're going to have third one, right? We had position, we had color, and now we're just going to have texture chords. So texture chords. So be sure to here say 3, right? Because we have 3 now, and this is the third entry. So format is float to the 2 times 2, binding, trade allocation is 2, why? Because it's 2 right over here. Then size of, so now we had here offset for position, right? 12 or 4 times x, y, and z. And here we're going to have offset of 3 plus 4 times size of float, right? Or that is how many? Is that 28? No, 16. Okay, I can do math. Yeah, it's 28. So basically we have 4 times sec y z plus 3 times 4 times GPA, right? Or we could take like this, something like this, right? We just have to offset for these positions and in these colors as well. And then we have to change our array style, right? We previously had 7, 3 plus 4 plus 2. So I'm just going to explain it here. So here we can say x, y, z plus RGBA. And for texture coordinate, it's common to use u and v. And then times everything, right? All of that times size of float, which is 4. And here, be sure to set the attribute count to 3. If I run it, it should still run, nothing is breaking, so it means I did alright here. So going bit further, we need to pass similar to here, we're just going to pass that texture and then its sampler, and this is going to be group 1. Why is it group 1? Right, because group 0 is used by vertex shader, but we now want to paste to fragment shader, so we're going to need different group. Be mindful, right? These groups, like group 1, can actually be also in vertex shader. For example, camera might be different group because it's kind of unrelated to transform, right? The camera, you can define it once and then you can paste same group everywhere in your code. But more on that also later. So it's binding 1, and here we can paste texture. So it's of type texture 2D, F32, and then the second one is sampler, and that's binding 1 now. Texture sampler, it's of type sampler, and then we can just say, is it sample texture? I think it is. I don't have IntelliSense here, but it should be this method. So we paste texture, texture sampler, and then this texture chords as last parameter. I think so. Maybe I can double check in my notes. It's texture sample actually. So no help from documentation here, but the parameters are at least alright. Yeah, it's good. Okay, so let's go forward. So now the most of the work is actually going to be in our pipeline because we need to define that layout of a group, right? We need to describe this layout, how it will look like, and then we need to paste data in that layout. So here we had transform bind group. So we had here transform, but I'm going to say here texture. So let's do it like this lazily. So I'm just going to rename this texture bind group layout and then texture bind group, right? So the bind group describes our layout and data, and this is actual data, right? So we're going to need to paste this when we create bind group, but we also need to paste it to pipeline, so that pipeline knows how the layout looks like. So we're going to need to paste it in 2 places, but first we need to create it. So create bind groups layout, I'm just going to say here transform, and then we can say texture. So as usual, we need to pass entries, bind group, layout, bind group, layout, entry, texture, bind group, layout, entries. So how many entries do we have? Well, 2. We have 2, right? One for binding 0 and the second one for binding 1. Binding 0 is our texture and binding 1 is our sampler. So we can say bind group, layout, entry 2. By 2 because here we have binding 0, which is used for our texture, and we have binding 1, which is for our sampler. So as usual, I'm going to copy paste just change all of this. So this is good, this is good. Shader stage is fragment, be mindful about that. And we're not describing buffer, actually we're describing texture here. New texture. So let's see properties. Sample type. It's float. Then we have multi-sampled. For now, no. So we can say false. Next in chain is not important here, and view dimension, it's 2D texture, so it's going to be view dimension 2D. Texture view dimension 2D. Hopefully you see this. I'm going to zoom in a bit so that's easier to see. And then we also have to describe a sampler. So we can say here texture, and here we can say come on, sampler. So 1, 1, 1, 1. Fragment is alright, but it's binding 1. Right? And here it's actually sampler. And for the sampler, we just have one property, which is type. And we don't really have 2, 3 samples, but ours is filtering. Okay. Let's see further. Okay, I can just create. I'm just going to copy. Then descriptor. So I'm going to call it texture descriptor. Texture bind group layout descriptor. If you want to be precise. So here I'm changing. So here we're now pasting texture bind group layout edges, and edge count is 2, right? And here it's texture bind group layout. And I think that's actually it regarding the layout. So if I try to run it now, it will fail. But that's quite alright. Let's see the error. Parent shader requirement against the pipeline. Shadable variables is not available in layout pipeline layout. Okay, cool. So that means it's not available in our pipeline, and here it is in our initialize, right? When we create a pipeline, we needed to create pipeline layout descriptor. So it means we need to paste it here. So we're just going to change this to 2, so that it knows that there are 2 entries, and then bind group layout. Second entry is our texture bind group layout. So that's going to fix almost. Just paste here 2 as well, right? We have 2 entries now. So if we do it, we're going to get different errors, which is okay. Right, this is complaining, this error. It kind of complains because we haven't pasted over here to our data. So I'm just going to break this into a couple of lines. So similar to how we paste transform bind group, we need to paste texture bind group, but we haven't created it yet. So let's do that here. So we have these create bind groups, but I'm actually going to handle this texture bind group differently. So I'm just going to say create texture bind group. So shamelessly copy paste as usual, right? Because we have this. So bind group entry. We're actually going to have 2 entries, right? One for texture and the other for sampler. So this is 1, 1. Actually, it's not buffer, it's texture view. And I mentioned that last time. We actually don't paste texture, we paste texture view, right? And that's why we created texture view here, if you remember from the last time. So we're going to paste that in, but actually we don't have texture yet. So let's quickly create a property here, public texture 2D texture. And for now it can be just get set. So that means that we're going to need to paste it. But here I'm going to say texture view. Size is not relevant in this case. So here we can say texture once again. then we can famously copy paste, say here sampler. Sampler is a binding one, and we have to change this as well, right? Then say sampler, and then we also created a sampler last time. And here we just have to say 2. I'm going to say here descriptor. This is alright. And here it's texture by group. Smooth so far. Then in our render, right, where we had this call. So here transform, and here we can say texture. So we just paste add group 1, and then we paste texture by group. Okay, if I try to run it, it will break because we haven't pasted the texture in. So let's fix that quickly. So here, before we initialize pipeline, right, we can say only train the pipeline texture is equal to texture. If I try to run it now, it crashed. It crashed because I probably forgot something, invalid bind group. So it means that I never called it, right? This is create texture bind group. So right here, after transform bind group, so I can say here transform texture, and you're going to see a bit later why I separated this into 2 methods, but let's try to run it now. Still something is wrong, but let's figure it out quickly. Number of binding is bind group descriptor does not match the number of binding defined in bind group layout 1. So let me translate this to something. Number of bind group descriptor. Aha, okay. It's actually when creating a bind group. So here, no. Where is the create texture bind group? But this is all right, right? Stack out bind group entries 0, 0, 2. Here we go. Transform bind group layout. So not here. So this needs to be texture bind group layout. So that's what I get for quickly copy pasting. But here we go. Right, we're almost there. Actually, these colors are all wrong, and that's very simple to solve, right? Because we paste here different colors and then we multiply by that color, so we get just about everything weird. But let's try it now. Okay, cool. Now we can play with some of the properties of the texture, right? And the most obvious one, and here I have some scaling from the last time, so I'm just going to say here 0 for now. So that doesn't scale, but we can play with some properties, and the most obvious one is this, and I call this kind of texture tiling, but if I try to increase all of these, right, you're going to see what happens. And what happens is this, right, because our texture right now, so what happens is this, right, usually it's 0 to 1, but by increasing to 2, right, we kind of sample to here, and then we start sampling again, but from 1. Right, if you paste 0 to 1.0, it will sample up to this point, right? But of course, it will be stretched to the geometry that we have, or our mesh. But here we can play with the properties because we don't have to sample it like this, right? We can say here mirror actually. So you're going to see what I mean. If we go, and I need to clear this. If we go to our texture, not texture, where we created a sampler, and this is in sampler util. So I guess you could paste these properties around, and I never use this label. So let me quickly fix that. Label is probably going to need to cast it to byte, Marshall. Yeah, that's okay. All right. So we have this edges mode, right? And we can say here clamp to edge, for example, but here we can say for v component, right, or our y, we can say mirror repeat. So if I try to run it now, you can see here the x is clamped to edge, so it means it's just going to be the last color, right, the edge color. but here you can see why it's actually flipped, right? And you can play with the properties here, but I think the three properties are mirror repeat, clamp to edge, and repeat, which is default one. So I'm just going to leave default one because it's usually the most used one. So yeah, we can leave it at that. With that said, I'm just going to fix this, actually not fix it, but return it back. The other thing that I wanted to showcase is this another property. And here, as you zoom in, you can see here how you can see pixels, right? It kind of looks pixelated. And what's happening is as texture is shrinking or increasing, right? You can have like 64 by 64 texture and map it to 64 by 64 pixels. Then it's perfect. But what if it's not perfect? Then you need to kind of resolve pixels somehow. And usually there are two modes to resolving it. One is called the nearest, which is the default one. So in the nearest, it will just take whatever the nearest color is and fill pixel with that color. The other one is, if we go to our sampler once again, we can say, right, min filter is linear. And there are really two options. And then make filter, right? We can set it to linear as well. And it will fix this kind of like rough pixels. Now what happens here, if it needs to resolve pixels and text cell is matching to colors or whatever, it will actually linearly interpolate between them or blend even better. So if you have here, for example, black meeting the red, it will actually blend to some middle color between them. So that's how it kind of works, almost. So just one thing that I want to actually fix, and that's very common, I like to do it in my engine. So here in our pipeline, here we kind of expect texture to exist, but I don't like to do that. I like to have default white texture. So I'm going to do that. We're going to have small static method, which is going to be called public static create empty texture. Ah, come on. So we need to pass in what? Engine. And we return texture 2D. Cool. So what I like to do is just have default 1 by 1 texture, which is white, so that our colors still work as properly, right? Because if color is divided by white, you get that color, right? Red divided by white is red. So let's do that. So I'm going to need another overload here. And here we're going to need to pass bytes as our data, but we're also going to need to pass uint width. Actually, let's do this as a vector 2 instead. Vector 2D uint size. So I need to import it. And then we're going to have, let's make this nullable. And then let's have our size as nullable as well. We can call it data. And then only vector 2D. Since it's struct type, it doesn't need to be nullable. So if we have pixels, right, and the size, we're going to use that instead of image and create a texture with that. So we can just assign this data is equal to data and this size is equal to size. Okay, we need to handle that here. Here we have texture, but we always assume that we have image. So we can say here if image is not null, right, we're going to use this overload. But otherwise, we can have another overload which takes the data in, and we need to create here and prepare for this. So as usual, I'm going to be very lazy. Copy and paste. Here we can say uint, sorry, not uint, what I need is vector 2 uint size, and then we can paste the data in data. So here it's just size X size. Actually, let's do width and height instead. Int width and height. Okay. So, no, this is alright, this is alright, this is alright. So we're going to need another overload for our write. And here, I think I might refactor this a bit, but I'm just going to copy paste it, and I'll write its engine texture, and here actually I'm just going to pass byte array. I'm going to say pixels, uint width, uint height. Let's keep it consistent. I'm going to change here as well. Okay, then we don't need this. That's alright. Pixels. We actually don't need pixels here, right? We can just remove it. It's pixels pointer, but here it's byte actually, so we can just change this to byte. And then it's going to work. And I can remove this because right now it's not relevant. Okay, well that's perfect. Because we can just change the pixels here. And we can probably then get rid of this, because if we just take this part where we're creating a pixels, right? And move it where we were reading from an image here, right? We can just move these pixels here. We already have uint width and height. So here, instead of passing image, we can pass pixels, right? And then we can pass width and height. So a bit of refactoring. We can get rid of this call with an image. And then sorry for, we can pass in data with height. All right. And then here as well, we can say texture, right? Texture is create. Actually, not here. Here, right? Because we have already the pixels, we can just pass everything in. So we can pass pixels with height. Come on. Oh, sorry. Image width, image height, and then label. And here it's complaining because this needs to be byte, but we can make this generic, right? If we say t here, right? Then we can pass any type of data. And for generic, I'm going to do it in a new line. Sorry. So we can say here where t is unmanaged. So it means unmanaged type. Unmanaged types are usually structs or these basic types: integer, unsigned integer, byte, unsigned short, stuff like that. Character as well. So we can say unmanaged, and then we can do that here as well. Right, we can pass tt. We can say where t is unmanaged, and here we just cast to pointer of t, and that will work because this one here also takes unmanaged type, or just a pointer. I probably need to cast this. Yeah. So if you get lost, here, I was going really quickly. Just try to look at the GitHub code because it's probably going to be more accurate there. You can just copy paste it, but what really we do is, let me just explain it. If we have an image, right, we only care now about the pixel information. So we just fetch pixels from that image and then pass pixels around, right? And then we need image width, image height. Then we hit the create texture, which now just takes the pixels, pixel array, right? As a sum t, where t is unmanaged. So it can be unsigned int, unsigned short, integer, short integer, right? Long, whatever. We create texture as usual, and then we just write it. And here write takes those pixels. and then it writes the texture. Right? And that's it. Right? We can try to run it. We get a fatal error because I haven't finished here, but here, so I mentioned that we're going to have different overload with width, size X, size Y, right? Data, it could be null or reference, but probably not going to be. I'm just going to say like this, because we really have two constructors, so it's either going to have an image or it's going to have data. And here now we can create the data, so I just need byte array, right? Data is new. Actually, we don't need this. I can just say it like this. So I really like this new array style. Kind of looks like JavaScript a bit. It's really good. So texture to be texture, new texture. So what did we say? We need our engine, data, sorry, here we actually need to pass 1, 1 for our size, then we pass data, and then we can pass label as well. So we're going to have string label, it's texture 2D by default, right? We can initialize it, and then we can return it. So that's it. We have our create empty texture. So in WebGPU only train the pipeline. We're actually going to change this to actually have some data, and our data is going to be private texture 2D. So I'm going to say texture, but I'm also going to have second texture, which is our default empty texture. Right? You can already guess what default empty texture is going to be. Here in our create resources, we're just going to say texture 2D, create empty texture, and we just need to pass engine, and here I'm just going to call it default empty texture. Right? Then we need to set our texture to it. Texture is default empty texture. And here we're going to say get. So what we need to return is texture. Then we need to say set. So if texture, if value is null, what is our texture going to be? Now it's going to be our default empty texture, otherwise else, right? Texture is going to be equal to value. And last thing that we need to do is just recreate that texture bind group, alright? Because we changed our texture, right? And if you remember our texture bind group, actually here we pass our texture data. So we need to recreate it, and then we can also get rid of it if it already exists. So if our texture bind group does not equal to null, right? We can destroy it. Texture bind group, sorry, our render engine, WebGPU, texture bind, what is it called, bind group release, and we release the texture bind group. But also we're going to do that when we dispose, and I haven't done this at all for other as well. So we had our transform bind group, and we can do the same for layout. So we can say engine, GPU, layout, bind group, layout release, texture bind group layout, and then the second one, right, is our transform bind group layouts. So layouts, bind groups. Sure. Let's go in order here. Something is crashing. I have an error. Invalid bind group layout for bind group descriptor. Cool. I guess now it's because I'm actually assigning it way too early. Could be. So if I move this, actually let's try without. So let's just see if this default works. And as you can see, it's white, right? Because why? We just created one by one texture, which is all white. So that works. And if I paste it here now, it should work. It doesn't, so let's fix it quickly. So I assume we call here create texture bind group. Let's see, texture is assigned, it's assigned here. So if I just use texture, maybe it's going to be a bit better. I don't think that does really make the difference. It shouldn't, right? So this is really interesting. Oh wow. So it's probably just this, right? I forgot to set it to null when we change it. Okay, it's not that. Okay, I found it. For whatever reason, this texture bind group layout here, it's null. As you can see, it's all zeros. So that's wrong. I probably need to review it a bit. And I guess the issue is that I tried to create it here while it's not ready to be created here. So let me just see where else do we call it? We call it here create bind groups, and where we call create bind groups here. And here we have resources, but these bind group layouts should exist by this point. So this is very interesting. And what was I doing here? Texture. So here, right? I was a bit ahead of myself, so now it should be fine, probably. Yeah, it is fine. So just make sure right now, you can probably handle it by throwing exception or whatever, but make sure never to set it before, right, this. Otherwise, it's just not going to work. And actually we can we do something about it? Yeah, we can probably say here if texture bind group layout does not equal null, right? If it exists, then we can create texture bind group, or you can throw exception, right? The pipeline is not initialized. That would be even more appropriate, I would say, probably because you want to initialize your resources. So the only thing that I wanted to showcase is just so that you see that our textures are created and how can you find them in debugger, and we're going to cover debuggers next time. I wanted to do this regardless because it's kind of useful to know all our resources. And if you see here, I cannot zoom in unfortunately, but as you can see here we have our texture loaded in, which is 248 by 248, and then we have this white default texture, right, that I created, and this is 1 by 1 white texture. So it's also used, and it's here in memory. So we have those two. This is how you can manage resources, and we're going to cover that next time. So yeah, that's it regarding this video. As a recap, do I need to do recap? Yeah, let's do recap just real quickly. So what we needed to do is pass the texture coordinates, right? That was the first step. And then we just added them here, and in our pipeline, we needed to add another vertex attribute, right? Because we need to describe it, and basically this is just description, but it was contained in, as you remember, when we created it's a vertex buffer, and then we paste in vertex buffer to pipeline, right? And my bad. Somewhere at the end, when we were rendering, we were passing that vertex buffer. Here is index buffer, right? Set buffers, right? We were passing that vertex buffer. Then after that, to use it, we actually had to define our texture 2D, which takes in texture view and our sample, right? And then we just have this default function in WGSL, which is called texture sample. We pass in texture, sample, and those texture coordinates, right? And how did we actually paste this texture sampler in our unlit pipeline? We first had to describe it somehow, and we do that with texture bind group layout. Right? We have created it somewhere over here in our create bind group layouts. We create layout. It needs to be pasted in two places. The first obvious one is before you can even create a pipeline, you need to paste it in, right? As a part of pipeline layout descriptor. And the second place where we needed it is when we create bind group, which is this create texture bind group, right? We paste that pipeline in, and here we also paste actual texture view, right, and the sampler, so that we could use it in our pipeline. One thing that we could do theoretically is you could create this texture bind group directly on texture and paste it from the texture. So that's possibility as well, and I leave that to you. I usually like to do it this way because then I can just release it and paste in whatever texture, right? And I'm going to create it on the fly when I need it. So similar to here. But to be fair, if it's on texture, right? It's one bind group per texture. So that's the benefit of it instead of one bind group per pipeline, but that's up to you to decide. I'm going to leave it to you. So if you want to really optimize, you have to think about it, probably put it on paper or something and then think about it. But anyway, we're done here. So hopefully you enjoyed this video. If you enjoyed it, maybe like, subscribe, or leave a comment. And the next time we're going to be going a bit deeper into debuggers. So that's it. Thank you for watching this video, and until next time.